Hi, my dear. Dami Rigetto. How are you? My dear, continually chapter 9. Flow in closed conduits under pressure. Part E. Flow through compound pipe system. Flow through pipes in series between two constant head tanks. Pipes in series are defined as pipes has different diameters and lengths connected together end to end, forming one pipeline. Take into consideration that the difference in water surface level between the two constant head tanks equal to the sum of total head losses in the series pipe as shown in the enclosed equation. Figure showing flow through pipes in series between two constant tanks. Flow through equivalent pipe sizes. It is defined as a pipe of uniform diameter having both the same discharge and total head losses of series pipes, which are different on length and diameter. Moreover, the length of equivalent pipe should be equal also the sum of series pipes lengths as shown in the enclosed equation. The calculation of head losses in equivalent pipe sizes as shown in the enclosed equation. Follow it, my dear, by yourself. It is so easy and clear. The rest of calculation, the head losses in equivalent pipe sizes as shown in the enclosed equation. The rest of calculation, the head losses in equivalent pipe sizes as shown in the enclosed equation. Flow through parallel pipes. Really, pipes in parallel are defined as a main pipe divides at upstream into two or more branches have the same length but differ in diameter and connect together at downstream again, forming a main pipe. The total discharge of the main inlet pipe divides upon all the branches, hence Q equal Q1 plus Q2 plus Q3. Accordingly, the head losses at all branches would be equal despite of differ on diameter as shown in the enclosed equation. Figure showing flow through parallel pipes. Flow through branched pipes. Really, branched pipe system is considered when there are three or more reservoirs at different levels connected together by a single or more junctions. The important is how to calculate the charge and direction of flow in each pipe under these conditions. It is assumed, as is case, for easier solution, that reservoirs are very large and hence the water surface levels in it will be constant. Moreover, minor losses are assumed also very small and considered negligible equal to zero. Supposable there are three pipes, 1, 2, and 3 are connected by three constant head tanks A, B, and C respectively and joined together at one point D. Hence, determination the flow velocity and discharge in each pipe and its direction are very important at this case. Direction of flow in each pipe depends merely upon the total energy value at the junction point D, which is equal to HD. Accordingly, Direction of flow in pipe 1 will be downstream because HA more than HD, and also in pipe 3 will be downstream because HD more than HC at all cases. On the other hand, the direction of flow in pipe 2, which connected to the middle tank P, depends mainly upon the total energy value at the junction point HD. Accordingly, to define the flow direction in this pipe, there are three supposable proposals as scale, as shown in front of you. Follow it, my dear, by yourself. It is so easy and clear. Supposable of no flow in pipe 2, and the charge of upper level reservoirs A equal to charge of lowest level reservoir C. Look, my dear, no flow in pipe 2 will occur as scale, and the flow velocity V1 and V3 and discharge also Q1 and Qc can be calculated as scale for each pipe by substituting equations as shown in the enclosed equation. Figure showing three pipes connected to three large condenser tanks and junction at one point D at case of no flow in pipe 2. Supposable of the charge of upper level reservoirs A less than the charge of lowest level reservoir C. Level of total energy line at the junction point D will be less than water level in the middle reservoir P at this case. Hence, the flow direction in pipe 2 will be downstream from reservoir B to the junction point D as shown in the enclosed equation. Figure showing three pipes connected to three large constant head tanks and junction at one point D at case of Q1 less than Qc. Supposable HD value, and accordingly the flow velocity V1, V2 and V3 and hence the charges also Q1, Q2 and Q3 can be calculated also as scale for each part by substituting equations as shown in front of you, my dear. Supposable of the charge of upper level reservoirs A more than the charge of lowest level reservoir C. Hence, level of total energy line at the junction point B will be higher than water level in reservoir B at this case. Hence, the flow direction in pipe 2 will be upstream from the junction point D to reservoir B as shown in the enclosed equation. Figure showing three pipes connected to three large constant head tanks and junction at one point D at case of Q1 more than Q3. Accordingly, the flow velocity V1, V2 and V3 and the charge also Q1, Q2, Q3 can be calculated as is case for each pipe by substituting equations as shown in the enclosed equation. Goodbye.